Hello guys, in this video we are going to discover the 10 applications of colligative properties. So this video will help you to remember colligative properties by discovering their applications in the daily life, and also will help you to become a smartass with your friends who do not study chemistry. Let's start with the first applications, the use of salt on the road during the winter time. When it snows, a layer of ice can form on the roads due to the presence of snow, but also to the low temperatures. Therefore, a layer of ice can form on the asphalt. And when this happens, an equilibrium between the solid ice and a thin layer of liquids, water, will be formed. So we will have two phases, the liquid water and the solid water, which are in equilibrium, one with each other. What does happen if we add salt onto it? We will destroy the equilibrium, because the salt will consume the liquid, and this causes the ice layer to exhaust itself in order to try to install again the equilibrium. But in the end, this equilibrium will be destroyed because no liquid will be there anymore, and so all the ice will be consumed. Therefore, spreading salt, not only we melt the ice, but also we avoid its formation, because thanks to the colligative property known as depression of freezing point, now water has a salt inside, so indeed it's a solution. And so the freezing temperature of water won't be 0 Celsius degree anymore, but will be lower. What salts are the most used one? NaCl, which is the common kitchen salt. It's cheap and easily available. And the second one is CaCl2. Now, if you remember the equation of colligative properties that I showed you in my previous video, I told you in that video that the equation for the depression of freezing point is the difference of freezing temperatures is given by the constant K times molality, which is the concentration, times Ni, which is the Van 't Hoff factor. Ni is the number of ions we have in solution. Now, if we look at these equations, you will realize that if you compare NaCl and CaCl2, the most efficient salt for deicing is CaCl2. That's because in solution, CaCl2 will dissociate in Ca2 plus 2Cl minus. So the Van 't Hoff factor for this salt is 3, whereas the Van 't Hoff factor for NaCl is only 2, because for NaCl only 2 ions will be present in solution instead of 3 like CaCl2. So a greater lowering of temperature is given by CaCl2, calcium chloride, which is indeed considered the most efficient salt for avoiding formation of ice on the roads. And of course, the depression of freezing point depends also on the amount of salt we put, and so depends also on the concentration. So the more salt we put, the more we will avoid ice formation even at low temperature, such as minus 25 Celsius degree or even minus 30 Celsius degree. Let's see now the second application of depression of freezing point. The second application I found for you, it's very similar to the previous one. It's the use of ethylene glycol in the car radiators. You may know that cars need a radiator with water inside in order to cool the engine. Well, inside this water there will be also ethylene glycol together with some additives such as colorants, for example. Why ethylene glycol is added to the radiator water? Because ethylene glycol will be our solute to add to the water in order to have a solution, and so in order to lower the freezing point of the radiator water. That's important to prevent icing of this water inside the radiator, which can damage the radiator and also the engine. However, ethylene glycol is not only applied for the depression of freezing point, but it's also applied for the elevation of boiling point of the same water. So ethylene glycol serves also to increase the boiling temperature of the radiator water. And that's important because the radiator water is circulating near to the engine, and the engine can reach very high temperature. And so also the radiator water can reach very high temperatures. So adding ethylene glycol to this water, we will use the colligative property, elevation of boiling point, in order to increase the boiling temperature of water, which normally is 100 degrees. And now the water can boil at higher temperature of 100 degrees, and this will prevent the formation of boil overs. As far as the elevation of boiling point is concerned, another common application of this colligative property is to say, now we know how to cook pasta. Why? Because if you take a pot, fill it with water, and then you have the salt on this water, and then you start heating, now, knowing colligative properties, you may think, this is a solution. So now the water won't boil at 100 degrees, but it will boil at higher temperature. So you may think it will take more time to boil this water. And so you may realize that it's more quick to do the other way around, which is take the pot, fill with water, put this pot with only water on the cooker, start heating, wait until water is boiling, and then add salt inside it. That's for sure true. But have you ever thought about the quantities? Let's do the math. Let's say I have 1 liter water with 10 grams of sodium chloride inside. Let's take our equation about elevation of boiling point. So delta T of boiling points equals K times M times N. So the ebullioscopic constant K for water is 0.512. M, which is the molality, is given by 10 gram of NaCl divided by the molar mass of NaCl, which is 58.44. Everything divided by 1 kilo of water, because 1 liter of water is also 1 kilo, okay? Because density of water is 1. And the Van 't Hoff factor, Ni, is 2 for sodium chloride. We have already talked about that. So the variation of boiling point, if we do the math, is 0.175. What does it mean? I remember you that delta T equals the boiling temperature of solution minus the boiling temperature of the solvent. So if you take the boiling temperature of the solvent and you put in the other side of the equation, you will have that the boiling temperature of this solution we have built equals 100 degrees, which is the boiling temperature of the solvent, water, plus 0.175. The result will be that the boiling point of this new solution is 100.175, which is about 100.2 Celsius degree, which is, nothing. It's only 0.2 degree of difference. So really, it's ridiculous. So cook pasta as you please. Another application of elevation of boiling point occurs in the sugar refining industry. During sugar refinement, the concentration of sugar is monitored by an instrument, which indeed measures the variation of boiling point temperatures. So this instrument uses the equation we have seen before. Why? Because if you know delta, the difference of boiling temperature, in this case of your solution with sugar, you can calculate M. M is the molality, so M is concentration. So this instrument can calculate the concentration of sucrose in these solutions. And in the sugar refinement industry, they need to know the concentration of sucrose in order to go on with the other processes which involve crystallization in order to purify the sugar and have the sugar like a white, pure powder you can find in the grocery store. Now, let's see some application for osmosis. We have seen the definition of osmosis in my previous video. I told you that if we have two solutions separated by a semipermeable membrane, osmosis is the movement of solvent from higher solvent concentration to lower solvent concentration through this semipermeable membrane. When this happens, this will create a difference in heat. But now let's see the applications of osmosis. The most famous application of osmosis is known to biologists or biochemists. They for sure know. They know that cells need osmosis for their nourishment or for exchange of substance with the external environment. What is a cell? Cell is not more than a box with a membrane around it, by definition. Probably I cannot pass the exam of biology with that, but let's go on. So this membrane works like the semipermeable membrane we have seen for osmosis. So what happens? If the cell is surrounded by isotonic solution, which means that the cell has the same concentration that there is also outside the cell. In this case, so in isotonic solution, nothing will happen. If the cell is in hypertonic solution, that means that the concentration inside the cell is less than the concentration outside the cell. Now this cell will lose water and will shrink. On the other hand, if the cell finds itself in a hypotonic solution, which means that the concentration of solutes inside the cytoplasm of the cell is higher than the concentration outside the cell, now the cell will absorb water and will swell up. So see as important is osmosis for the cell life. Osmosis is also important for plant life. Plants absorb water and food too through their roots thanks to osmosis process. Osmosis comes into play also when you have a bath. If you stay in the water for a longer time, you will notice that your fingers will become wrinkly. Why? Because of osmosis process. Your hands have less water inside than the water that there is in the bath. So they will absorb water and become swollen and wrinkly. Osmosis comes into play also when you have a sore throat. When you have a sore throat, the cells around your throat are swollen because they are filled with an excess of water, and this causes you pain. So what you can do, if you know osmosis, you can do gargles with salty water in order to reduce the pain. Why? Because if you do these gargles with salty water, now, since the salty water is more concentrated, now your cell around the throat will lose water, which will go inside this solution you are using. And so the cell will shrink and cause you less pain. So we have ended up with medicine, as you can see. And indeed, the last application of osmosis I want to tell you is dialysis. But however, I'm not a doctor, so I have decided to call my personal doctor, which will help us to understand what is dialysis. So doctor, are you there? Yes, here I am. I will explain you what is dialysis. So unfortunately, some of my patients who came here with kidneys problem, their kidneys is not working anymore. So they have a blood which is full of trash, and because you know kidney, they are a filter of the blood. So if your kidneys are not working anymore, then your blood will be full of trash and excess of liquids and so on. So you need to purify your blood. So I tell to my patients, let's do dialysis to clean your blood. Dialysis, which involves osmosis, is the peritoneal dialysis. In this case, the membrane is the natural membrane of your belly, which is called peritoneum. This membrane is placed in contact with the dialysis fluid. This liquid has a precise concentration of solute inside. Generally, this solute is glucose. Now, during dialysis, the dialysis fluid will come into contact with the blood. And so an exchange of solvent between these two solutions will happen. In particular, the excess of water in the blood will leave the blood and flow into the dialysis liquid. And so the excess of liquids which were in the bloodstream now will go into the dialysis fluid. And so with this technique you can understand that you can replace the function of kidneys. So peritoneal dialysis use osmosis for replace kidneys. That's in summary. I hope everything was clear. Yes, everything absolutely clear, doctor. Are you sure? You looks like lost. Me? No, everything clear, really clear. Bye, doctor. So for this video is everything. I hope this video can help you. Write me in the comments if you know other colligative properties applications, and bye.